This is our last lesson on factoring and using factoring to solve equations. So it's going to be one of the more challenging sections. Here's some tips just to go by as you're progressing through this section. First of all, anytime you're going to factor, you must look for the GCF first. Anytime you can take out a common factor first, it's going to reduce the amount of work and also the level of difficulty of the problem itself. The other thing I want you to look for are some special factoring types, like, for example, a difference of squares, or maybe even factoring by grouping if there's 4 terms. So keep an eye out for those. Let's try just to review with some regular factoring problems, and then we'll eventually work our way towards solving equations. So first thing, we need to look for a greatest common factor. So think to yourself, is there anything in common between 2x squared, 12x, and 10? And yes, there is, the number 2. So I'm going to factor out 2 and write what's left over in the parentheses. This takes this trinomial, which currently is rather difficult, it has an a value other than 1, and makes it into one that's pretty simple with hardly any work to show at all. All I need to do now is think of 2 numbers that when multiplied together, they multiply to be 5 and they add up to be 6. And we know that as 5 and 1. Now notice how I carried down the 2. Even though we factored it out, it's still part of the problem. So 2 is still there, it's just that the rest of it can be factored. Okay, next one. Example 2, is there a GCF? Yes, there is. There's 4 goes into both of them. Now this kind of resembles a difference of squares, but the key word here is difference. This one has a plus sign. The difference of squares only applies to subtraction. So if that was subtraction, we would still completely factor it. But because it's a plus, this is done. Doesn't look like it, but it's done. No additional factoring techniques can be used to break this down. In this next one, think to yourself, is there anything in common? I know they're both even, so you can at least take a 2 out. That leaves us with 16x squared minus 25y squared. And even though 16 and 25 are big numbers, they don't have anything in common, so they're going to stay there. But I do recognize this as something else. That's a difference of squares. Just as a reminder, here's what it looks like. A squared minus b squared equals a plus b times a minus b. You just have to figure out what the a and b are. The a is the first thing, squared. So a here must have been 4x. B is the second thing after the minus, but it's squared. It had to have been 5y. To finish this, I'm going to carry that 2 down and then just write the difference of squares. A plus b times a minus b. It's really long, but that's the complete simplification. Let's jump right into solving equations. They should look kind of familiar because you've seen everything, just not all at one time. So for this first one, let's begin by putting a 0 on one side. And then think to yourself, is there anything in common? And there's an x in common. The zero product property says that one of these 2 factors has to be 0, either the x or the x minus 25. By adding 25 to both sides, we get the answers x equals 0 and x equals positive 25. The next one is already equal to 0, so we want to start by thinking, is there anything in common? There's an x in common. But I can't stop here like the last one. That x squared minus 36 can be factored as well. It's a difference of squares, where a is equal to x and b is equal to 6. So I'm going to carry the x down and write a plus b, a minus b. There are three different factors here that need to be considered. Either the x is 0, or x plus 6 is 0, or x minus 6 equals 0. That gives us three separate solutions: 0, -6, and 6. Okay, let's look at this one. Unfortunately, there are no greatest common factors. This is kind of stuck the way it is. And another kind of bad thing for us is that there's a number in front of the x squared. These are the ones that took more work. The method I suggested for you is to multiply the two numbers together, the outside and the insides, and then come up with a target number. In this case, our target number is -30. We're trying to think of two numbers that when you multiply them together, you get -30, but when you add them, you get the -13 in the middle. We have lots of different things to consider. So let's see here. If we can make a list, like 6 and -5, or -6 and 5. 15 and -2, or -15 and 2. 10, let's see, -30 and 1, or 30 and -1. And then we have 10 and 3. So 10 and -3, or -3 and 10. As we examine all these different possibilities, we find it right here. -15 and 2 will give me that -13 in the middle. So what we did was we went ahead and we wrote the problem, but instead of writing -13, I wrote it as -15x plus 2x. It was a very special way to write this problem. So the inner two parts here actually total -13. We haven't changed it, just written it in a special way. This created factoring by grouping. In the first two terms, there is a 5x in common. So I'm going to factor that out. In the second two terms, it just so happens for this problem there's nothing in common, so I'm just going to write a 1 there. But what you see is we've created common factors. I'm now going to take out 2x minus 3, and so 5x plus 1 remains. Either 2x minus 3 equals 0, or 5x plus 1 equals 0. Two small equations to solve. It looks like we'll have two solutions. X can equal 3/2, or x can equal -1/5. Okay, let's start from scratch. Greatest common factor. Do you see anything in common? There's that 2. Everything's even, so I'll take that out first. And now, instead of being one of those really challenging problems, this won't be bad at all. I just need to think of two numbers that multiply together to give me -20, but add up to be 8. For this one, I'll use +10 and -2. If you can't think of those factors in your head just doing mental math, make a list just like we did in the last problem. We have 3 different factors that could potentially equal 0. However, 2's not going to really work. 2 doesn't equal 0, and it never will. So I'm going to skip right to the x plus 1, or x plus 10, because x plus 10 equals 0, or x minus 2 equals 0. We're going to have two solutions for this one. X equals -10, or x equals +2. This last problem is probably the most different of all the things we did. It actually looks like it's almost done, like you could just set each one equal to 40 and be done. However, the zero product property only works for 0. So x plus 1 does not equal 40, and neither does x plus 4. what we'll have to do is kind of work our way backwards before we actually finish. I'm going to begin by foiling this problem, getting it in an expanded form, because eventually we'll have to combine that 40. When you FOIL on the left, or expand it, I get x squared plus 4x plus x plus 4. This combines together to be 5x's in the middle. This is what the problem used to be before they factored it. What we need to do is get a 0 on the right-hand side. I'm going to subtract 40 from both sides. And then start the FOIL process, trying to find those factors. We need to find two numbers that multiply together to give negative 36, but add up to be 5. This number has a lot of factors, so I think I might jot them down, like 36 and 1, 4 and 9, 12 and 3, it's also even, so we'd have negative 2 and 18, or 2 and negative 18. I think I found it right here. Our factors are x minus 4 times x plus 9. So either the x minus 4 equals 0, or the x plus 9 equals 0. Two solutions, 4 and negative 9.